So now that we've walked through the structure and functionality of the Zippy microservice, let's take a look at its implementation. In particular, we're going to take a look at how the ZippyController and ZippyService classes are implemented, as well as briefly the Zippy application itself. And we'll also show how we can implement a custom SQL query using the various JPA programming API methods. And this is also going to demonstrate how to do a very simple, thin reactive encapsulation of the Jakarta persistence API. Remember, the JPA is synchronous, but we want this thing to appear to clients in a more asynchronous or reactive way. So as always, you can get the code here at my website, so please feel free to take a look and follow along. So here we are in the Zippy microservice module in the EX3 project, and we're going to quickly take a look at the Zippy application. Again, no real surprise here. It's just an application that extends the base application, provides a main entry point to run the microservice, also has a little bean that you can uncomment in order to print out some information from the database repository. In this case, it's the JPA quote repository. So that's a simple way of being able to figure out what's in it for debugging purposes. Here's the controller. Nothing real earth-shaking here either. Same as we've seen before. Just forwards on to the service and serves as kind of the conduit between the world of HTTP requests, both put and get requests, and the world of Java types in the Java service. Here's the Zippy service. Now, this is a little tiny bit different from the Handy service. So a lot of it's very similar. The main difference being, first of all, we're making calls to a JPA quote repository. So we've wired ourselves to talk to the JPA quote repository. So that's a little different. And because of that, which comes back as a list, we have to convert the list to a Flux. So we do that by using the Flux from iterable method. That converts the list to a Flux. We do the same thing for post quotes. We convert the list we get back from doing find all by IDs on the repository into a Flux. Notice that that doesn't actually make the thing run asynchronously per se. It just returns something in a way that will look asynchronous or reactive to the client. Now here we actually do something that's a little different, and this is basically using some features in Project Reactor as well as a call to the JPA to locate all quotes whose quote field matches the list of queries, and we return them as a flux of quote objects. So let's take a look and see how this works. So we take the list of queries and we convert that into a flux. And then we convert that flux into a parallel flux, and we run this parallel flux on the bounded elastic thread pool. And we do that because these calls will be blocking. We then use the flat map to flatten the flux of fluxes into a single flux that contains the quote results. And then we go ahead and we say M repository find by quote containing ignore case for the query for each query. So in parallel, we're going to look up each query using the JPA, which will synchronously return that to us. We take the list that comes back from the find by quote containing ignore case method, turn it into a flux, and then we flat map all those things together to have a flux of quote objects. We then convert the parallel flux back to a sequential flux, and then we use the distinct operator to ensure that duplicate Zippy quotes aren't returned. It'll basically winnow out anything that was have been a duplicate because we were doing these queries in parallel. Then the last method in the service just forwards to find all by quote containing ignore case all in, which is that mouthful, and that comes back as a list, and we turn around and turn that into a flux as well using the from iterable factor method. So everything that comes back to clients is a flux, and this was the only method that didn't just forward directly over to a corresponding method in the repository, the JPA repository. And I did this mostly just to show you a different way to do things. So let's take a look at the JPA quote repository. This is a JPA repository, and it also extends multi-query repository. And it's got this method defined in it using the Spring Data API keywords called find by quote containing ignore case. Now, we also want to be able to have a custom query. And so we get that by basically extending the multi-query repository. And the multi-query repository has this method that's long-winded called find all by quote containing ignore case all in. And that particular method is the one that we have to write the implementation because Spring doesn't know how to generate that automatically. So let's go take a look at that implementation. Now this implementation is going to use the JPA Entity Manager classes and methods. So we have an entity manager that's defined here as a field. We have this long-winded mouthful of a method, which takes a list of queries, and it uses API calls on entity manager and associated classes. So the first thing we do is we get a criteria builder from the entity manager. Then we go ahead and we create ourselves a criteria that is associated, create a query that will be associated with a quote class. And then we go and we are going to create a root object to specify the entity to query, which again is the quote class. And then we go over here and we use the criteria builder in order to get ourselves an expression object that represents a lowercase quote column / field of the quote entity. So that's the quote entity. Now we're going to go designate one of its columns, and we'll use that to create the search predicate that matches the specified queries. We then make a helper method called getPredicates, passing in the queries, the criteria builder, and the quote expression. And what that does is that goes ahead and converts the list of queries into a stream. We convert each of the queries to lowercase, and then we're going to go ahead and use the map operator. This is the streams map operator to create a like predicate that matches the quote field of the quote entity. So we're going to go ahead and create a like predicate looking at the query, each of those queries we have. And then we're going to create a conjunction object, which is going to return as a predicate, as you can see here. And what that's going to do is it's going to basically reduce the list of predicates into a single predicate, which is the conjunction predicate or the and predicate. So that's what we get back here is a predicate that ands all these things together. And then we take that and predicate and we pass that to get query results along with the criteria query and the quote expression. So let's go take a look at quote query results. As you can see, quote query results uses the entity manager to make a query, which we're going to give the and predicate as the where clause. And then we're going to group the results by the quote expression. This should actually say quote expression, not ID expression, because this is not the ID, this is the quote. And let's just make sure that that's named properly. So as you can see here, that's going to create the query, and then we go ahead and execute the query and return the results as a list of quotes. That's what comes back here, and that's what comes back here as the result of this long-winded mouthful of a method. And so that, of course, is what gets returned here to the service right there. So we're going to wrap up that list of query results into a Flux and return it back. So that's all the code portions of the Zippy microservice. Let's take a quick look at some of the declarative parts and the resources portion. We have the schema.sql file, which says I've got an ID, which is the primary key that's a serial int, and I've got a quote field, which is an array of characters not to exceed 1024. This is the quote table. Here's the data. So you can see we're going to insert into the quote table the following data. So we have the default value that's just this auto-incrementing number that goes from 0 to the number of quotes minus 1. And then here we're going to have all the Zippy the Pinhead quotes that I'm familiar with. And you can see there's a whole bunch of them. There's more Zippy the Pinhead quotes than there are Jack Handy quotes, which I'm not sure what that is a sign of or indicative of, but it's just the reality. And as you might expect, if you look far enough into the Zippy quotes, you'll see a bunch of quotes that say yow, because that's something that Zippy says all the time. He's always saying yow. So lots and lots of yows. So that's the data. That data is then used to populate the database based on the application YAML file. You can see here we have the server port is 0, which indicates Eureka should select the server port. We also tell Eureka that we want to be a Eureka client, please. We set our name. We set ourselves to use the JDBC database connector. So that's the Java database connector. I guess it's Jakarta database connector now. And that's an in-memory database with these flags. We disable passwords because we don't care about that for this. If you wanted authentication, you could add it, of course. And then we set a few other things that just ensure that we can debug this from the console. So that is the end of our Zippy microservice implementation. Not quite as cool and reactive as the handy one, but demonstrating how you can kind of mix and match more traditional synchronous style programming with JPA with clients that expect to get things back in reactive web Flux style reactive types.